This is 2010 1E. So it was found that 50 centimetres cubed of my hard water sample, which is my ones that contain my N2 plus or calcium 2 plus ions, required an average of 9.20 centimetres cubed of 0.01 molar EDTA. Now, we're then told that's before ion exchange, so I'll just put that as before. And then we are also told that I have 2.4 centimetres cubed after. I'm not going to concern myself really about the after first, because in the question I'm asked to calculate the total hardness of water before ion exchange. So that's what I'm going to do. So I have 0.01 molarity, which is moles per litre in 1,000 centimetres cubed. In this question, I don't have 1,000 centimetres cubed, I have 9.2. So 0.01 multiplied by 9.2 divided by 1,000 gives 9.2 by 10, it's the minus 5 moles. Okay, next then what I have to do is I have to see how much of that is my water sample, so 1 is to 1. So if I have 9.2 by 10 to the minus 5 moles of EDTA, I'm also going to have 9.2 by 10 to the minus 5 moles of my Ca2 plus. I'm asked for moles per litre, so that's 9.2 by 10 to the minus 5 moles. And in this question, it's 50.0 centimetres cubed. So I have to find what's in 1,000 centimetres cubed, multiply by what I know, divide by the bit left over, 50, and that gives me 1.84 by 10 to the minus 3 moles. And that's my answer to part I. Okay, part 2 then, I'm asked to find that then in grams per litre. So number of moles equals mass in grams divided by my relative molecular mass. And again, in terms of CaCO3, that's 40 plus 12 plus 16 by 3 gives 100. So 1.84 by 10 to the minus 3 multiplied by 100 gives me a number of moles, or number of mass in grams of 0.184 grams per litre. And finally then I'm asked for that in ppm, multiply it by 1,000, and that gives me 184 ppm. Now, next part then you're asked to repeat these calculations for the water after ion exchange. So after ion exchange, again I have 0.01 moles of EDTA in 1,000 centimetres cubed. But if I look here, I was told in the question that I only needed 2.4 centimetres cubed after the ion exchange. So 0.01 multiplied by 2.4 divided by 1,000 gives 2.4 by 10 to the minus 5 moles. Okay, now that is my number of moles in EDTA, so I then need to put that in a ratio. So if I have 2.4 by 10 to the minus 5 moles of EDTA, I also have 2.4 by 10 to the minus 5 moles of my calcium 2 plus ions. That is my number of moles, and I was told in the question again I used 50 centimetres cubed. So to get my number of moles, I multiply by 1,000 and I divide by 50, which gives me an answer of 4.8 by 10 to the minus 4 moles. Then I need to convert that into grams per litre. Okay, I've worked out my MR is 100, so it is 4.8 by 10 to the minus 4 multiplied by my relative molecular mass, and that's going to give me grams per litre of 0.048 grams per litre. And then to convert it into ppm, multiply it by 1,000, 48 ppm. And that's your answer to the 2 questions.